Good morning, everybody, and happy Monday. So, this week we are going to practice solving systems of equations algebraically. A system of equations, again, is a fancy word for two or more equations. We are exclusively dealing with the two aspect of this. We aren't going to have any times that we're going to be dealing with three equations in this. You might have to do that in some higher level classes. We're not going to be doing that here. So, the alternative to graphing, and just a little review on graphing. We're not going to actually review this. We did a little bit of graphing last week, but when you graph a system of equations, you graph both lines, and you're going to get one of three things. They meet, and that is your solution. You could have one line, so we could see one solution, all or infinite solutions, or the other thing we could see is parallel lines where there are no solutions. So no solution as well. So remembering that the solutions are the points where both equations are true at the same time. So that's what we're looking for. Either when we graph them, this is where they're both true. If they're the same line, they always are the same. And if they're parallel, there's no numbers, no ordered pairs that fit both. So substitution, little reminder, and this is worded a little poorly, but or a little confusingly. One equation is solved, so we solve one equation for one variable. This makes a lot more sense when we're doing it, and that's either variable in terms of the other. So for example, like we did with graphing, where we put things into y equals mx plus b form, that is solved for y. So we're going to get one of our variables isolated. And then we substitute that expression for the variable in the other equation. And the answer in the end will be an ordered pair. So on the homework, there's three different things. I want you guys to follow along with the homework assignment while you're doing this. Do this on just some scrap paper. So for this, let's look at y is already isolated in our first equation. Now we're going to substitute the expression. So the expression y equals 4. So in the other equation, every time we see y, we just put the number 4 instead. And then we solve for y. We solve for x then, and then we'll solve for y. But we already know what y is. Y is 4. This is one of those lucky ones where we already know what y is. So the first two on your homework assignment are easier like this. See if you can plug y in. Let me get you started. 3x plus 2 times 4 equals 11. See if you can solve for x. Go ahead and pause it and give that a try as I'm typing away here. All right, thanks for trying that, guys. Plus 8 equals 11, right? All I did was multiply 2 times 4. Now, I want to get x by itself. I'm going to subtract 8, and I get 3x equals 3. Divide by 3, divide by 3, x equals 1. So our final answer here is just going to be 1 and 4, right? That is easy enough, isn't it? I know y is 4 because it's already up here, right? If we graphed these, they would have met at 1 and 4. Y is 4 is this line right here, and the other line would have intersected like this. So this point right here, x is 1, y is 4, that's where they meet, right? So this next equation is a little bit building on it. This last one right here, this makes sense. This is easier. I'm plugging in the number 4 for y. This next one, x is already isolated, but this is the equivalent expression. This is the expression for x. X is this. So this time, what we're going to end up doing is it's going to be 2 times, and we're going to substitute this whole fancy shindig in for x, plus y equals 9. So I want you to pause and take a minute to try and solve for y. All right, plus y equals 9. So when you multiply this through, you get 6y plus 1, 6y plus 2, plus y equals 9, right? I distributed 2 times 3y, 6y, 2 times 1, and now we're going to get 7y plus 2 equals 9. I'm going to subtract 2 from both sides. 7y equals 7, and we should get y equals 1. So now we've solved for one variable. After solving for one variable, we plug it into the other equation, and we solve for the other variable. So what that means is we're going to go like this. X equals 3 times 1 plus 1. 3 times 1 is 3 plus 1, x equals 4. So here we're going to wind up with an ordered pair. X is 4, y is 1. Our answer should always be in an ordered pair for a solution. So this is a little more difficult than the first one, but not much. Instead of substituting in just a number for x, we substitute in a phrase, right? That's actually, we learn later on, a binomial, right? 3y plus 1, a whole phrase. And we put it in parentheses to protect it, and we distribute the 2 to the whole thing. Now we have one last problem. This time we have a little bit more work to do. Y minus 2x equals 3. First, we have to isolate one of the variables. So I'm going to add 2x to the other side to get y equals 2x plus 3. And now, now it looks exactly like the last one. I have a variable isolated. That means I'm going to substitute in y into the other equation. So right here we have, so does this make sense? Before I move on, what I did here was, all I did was I picked one. I picked this one, this equation, because y was closest to being by itself. I don't have to divide y by anything to get it by itself. Now I'm going to take the phrase that I found, the same phrase from earlier, 2x plus 3. You know what y is. This is what y is, right? Y equals 2x plus 3. So over here, I'm going to put 3x minus 2 times 2x plus 3 equals 5. That's really no I mean, it's getting progressively more difficult, right? Here I just substituted in 4 where y is. Here it gave me x equals 3y plus 1, and I put it there. Here I had to solve for y. I had to isolate y first, and then I put that in parentheses. So take a minute and try to solve for x. Pause and try that. So remember, we kind of think about it like there is a hat on the -2. -2 gets distributed to everything. So we get 3x minus 4x minus 6 equals 5. All right. So what we're going to do here now, and thanks for trying that on your own, is just really solve for x, right? So we have 3x minus 4x is negative x. And we add 6, negative x minus 6 equals 5. Now we have negative x minus 6 equals 5. We're going to add 6. Negative x equals 11. X equals negative 11 is our answer. So when it says, now we plug this in to either of these, it does not matter which one, and we get y minus 2 times negative 11. I'm going to pick this one, equals 3. All I did was I put that value of negative 11 in for x. Y plus 22 equals 3. I'm going to subtract 22 from both sides, and I get y equals negative 19. So we got pretty big numbers in this one. Let's try the other one, shall we? Just to make sure that it's the right answer. 3 times negative 11 minus 2y equals 5. Negative 33 minus 2y equals 5. I'm going to add 33. Negative 2y equals, when I add 33, we get 38. And when I divide by negative 2, we get y equals negative 19. So either way, we got negative 11, negative 19. So again, no matter how we do this, whichever equation we solve for up here to begin with, and wherever we plug it in, if we follow these simple steps here, we're going to get the right answer. It doesn't matter once I find what x is, which equation I plug it into. But when I solve this equation, y equals 2x plus 3, I have to plug this into the other equation. After solving it, we plug it into either. So the first time we solve, we plug it into the other equation. Once we have this, we plug it into either. Just a couple housekeeping notes. If we get to something that is never true, like 1 equals negative 2 or negative 1 equals 1, there is no solution. How that would look like on a graph is parallel lines. If we get something like 1 equals 1 or 9 equals 9, there's infinite. What that looks like on a graph is two identical lines. The questions we've done so far, they look like more like this. They have one solution, one point where they meet. That's what we did today. That's what those three we worked on were. But if you see something where there's 1 equals 2 or negative 1 equals 1, that means there's no solution. And if you see something that's like this, that means there's infinite solutions. Kind of like with equations and the number of solutions for equations earlier in the year. All right, so shoot me an email if you need any help. The answers to all the three questions that I didn't do that you have to do are going to be in the assignment, but you do have to show all your work. Thank you and have a great day.